Okay, welcome back to our third and final video of this section of Chapter 4. We still have a few more things to go over in Chapter 4, but we're going to talk now about the net ionic equations. Net ionic equations, what are they? Well, a net ionic equation shows only the reacting species in a chemical reaction. So those ions that appear on both sides of a complete ionic equation are not included in net ionic equations. These ions that appear on both sides are known as spectator ions. They're kind of there just hanging out, watching everything happen, but they're not actually actively involved in the bonding or the reaction itself. So net ionic equations will not include these spectator ions. You will need to know your solubility rules in order to determine what ions will form insoluble solids and which ions will stay in an ionic form. A net ionic equation will only show the reacting species, will not include spectator ions. So there's a process you can follow to write this. First of all, you want to write a balanced complete equation showing all the species present. You want to make sure that you show all of the reactants and that you show all of the products and that the equation is balanced. Next, you want to break anything that is in aqueous form into ions, because if it's in aqueous form, that means that it is separated in ions in solution. So we can break down both of the reactants and one of the products. Now, the cadmium 2 sulfide is a solid, so we keep that as a compound. We do not break that up. After you've broken up the aqueous substances into ions, you want to go through and cancel out the ions that appear on both sides. So in this equation, nitrate appears on the reactant side and the product side, as well as sodium. It appears on both sides, so we can cancel those out. Now the things left behind are the ones that are going to make up our net ionic equation. So we write this balanced net ionic equation. We have our cadmium 2 ion, our sulfide ion, and they will bond together to form the solid cadmium 2 sulfide. So the rules for writing the net ionic equations are: first, you want to write a balanced complete equation showing everything present. Then you want to break each aqueous substance down into ions. You're going to cancel out the ions or the spectator ions that appear on both sides. And then finally write a balanced net ionic equation. When you are doing net ionic equations, you want to assume that all reactants are taking place in water and that all reacting substances are ionic. So let's try another one. We have sodium hydroxide reacting with iron 3 chloride. This is a double replacement reaction. So the ions are going to switch places, and sodium will bond with chlorine and iron 3 will bond with hydroxide. Knowing your solubility rules, you should be able to identify that iron 3 hydroxide is insoluble. So it is marked as a solid. See the S in parentheses after the iron 3 hydroxide. Now we want to balance this equation. So we go through, we need to add a 3 in front of our sodium hydroxide in the reactants, and we need to add a 3 in front of our sodium chloride in the products. Now we're balanced. Once we're balanced, we're going to take anything that has an AQ in parentheses after it and break it up into its ions. So doing that, you'll notice everything breaks up except for that iron 3 hydroxide in the products. That is a solid, so it stays as a compound. Now go through, cancel out the ions that appear on both sides of the equation. You have your sodiums on both sides and your chlorines on both sides. And then write your balanced net ionic equation. So 3 hydroxides will react with an iron 3 ion, and it will form an iron 3 hydroxide solid. Remember to take your coefficients with you. After you cancel out your spectator ions, any coefficients left on ions in that reaction need to come down to the balanced net ionic equation. So again, let's recap these these steps in writing balanced net ionic equations. First, you're going to write a complete balanced equation. This is with the compounds intact. Then you're going to break each of the aqueous substances into the ions, canceling out any spectator ions. Once you've canceled out the spectator ions, you're going to finally write a balanced net ionic equation. That is the end of our net ionic equation video. Please make sure that you remember the steps in writing net ionic equations because we're going to have plenty of practice in class.